When the fan turns, it is designed to expel the warm air and to draw in cooler air. That is how the fan works. It blows its air directly onto the heatsink. The heatsink also cools the CPU down here. Are you with me? And so this is the cooling system for this computer.
You may already know that there are many important parts inside a computer, but what exactly do they do? Let's take a look inside and learn about the various components that make a computer work. Whether it's a desktop computer or a laptop, every computer has a large circuit board called a motherboard. This contains some of the most important parts of the computer, such as the CPU, also known as the Central Processing Unit or processor. The CPU can be considered the brain of the computer because it processes information and carries out commands. Since it tends to get hot, it's covered by a piece of metal called a heatsink, which draws heat away from the processor. The motherboard also contains the computer's RAM, or random access memory. This is the short-term memory that the computer uses whenever it's performing calculations. However, you cannot store your files there, because the RAM is cleared when you shut off the computer. The hard drive provides long-term storage, keeping all of the computer's data even when it's turned off. Many hard drives use a magnetic platter to store data, but many newer computers have solid-state drives, which are faster and more durable, but also more expensive. On many desktop computers, the motherboard has expansion slots that allow you to upgrade by adding expansion cards. You can add a video card to get better graphics performance, or you can add a wireless card to connect to your wireless home network. Most laptops, however, don't have expansion slots. Of course, the computer's components need electricity to run. The power supply unit is designed to take power from the wall outlet and send it to all of the different components that need power. Laptops also contain a built-in battery that lets you use them anywhere. A computer is a pretty complex machine, but now that you've seen what goes on inside, it should be a little less mysterious.
Alright, good morning class. Alright, thank you all for coming back to class. Today we want to continue with our studies on computer hardware, and we'll be looking at the heatsink and fan. And it says that the heatsink is an aluminum device that is placed directly on top of the CPU. So we know the CPU, the heatsink is placed directly on top of it. Number one, to absorb, and number two, to expel. Absorb, expel the heat generated by the CPU. It is placed directly on the CPU to absorb and expel the heat generated by the CPU. This is done in order to control the temperature of the CPU and to keep the computer from overheating and damage. That is very interesting. We have to understand that the CPU produces a lot of heat. The last time we talked about the CPU, have you seen the CPU? We talked about the CPU and we learned that the CPU is the brain of the computer, the master chip in a computer that does all the processing, the arithmetic and logical operations in our computers. In doing all that work, the CPU generates a lot of heat. As a matter of fact, inside the computer system, the number one device that produces a lot of heat is the CPU. There is no other component that produces heat more than CPU. The CPU is what gets hot in your computer. If you hear that a computer is hot, a laptop is so hot, it is the CPU that is really hot. Now, the CPU can get hot, but it shouldn't reach a certain limit. And so the temperature of the CPU needs to be regulated so that it doesn't get to that limit. If the CPU's temperature gets to a certain limit, what will happen is that your machine will be turned off instantly. So you'll be using a computer and it will go off all of a sudden. And that is good, because they have programmed the computer to shut down all of a sudden to prevent it from damage. Because if it doesn't shut down like that and it continues, your machine is going to fry. It's going to be completely destroyed. And so going off like that is even a good thing. And so you cannot use a computer for more than 10 minutes if the heat is not regulated. I repeat, you cannot use a computer for more than 10 minutes if the heat is not regulated. In every computer, there needs to be a cooling system. There needs to be what? A cooling system. That is a system designed to cool your computer. Most computers make use of what we call the heatsink and the fan. Please, have you seen this? This is a heatsink and there's a fan on top. Some of them have fans directly on top of them. This is a heatsink. Some of them have fans on them. Some of them have fans next to them. And some of them have fans a little bit away from them. But there is always a fan closer to the heatsink. Are you with me? Over here it says that the heatsink is an aluminum heat exchanger that is used to draw heat away from what? The CPU. It transfers the heat generated by the CPU to a fluid medium, often air or liquid coolant, where it is dissipated away from the computer, thereby allowing regulation of the computer's temperature at optimal levels. That's wonderful. So this is a good heat sink, and you can see that there's a fan on it. Now the fan is called the cooling fan. Sometimes it is called the computer fan. Other times it's known as a system fan. It's a fan that is used to draw cooler air into the computer case from the outside, expel warm air from the inside, or move air across the heatsink to cool the CPU and other internal components. It is usually attached directly to the heatsink, and there may also be multiple fans within the computer case. That's what I wanted to tell you. Now, there are some computer cases we are going to find more than one fan. There are some computer cases we are going to find more than one fan. In this lesson, our focus is the fan directly connected to the heatsink. And that fan helps the heatsink to cool the CPU that is under it. Are you with me? The way the heatsink is designed, it is designed to absorb heat. The way it is designed, whatever it is attached to, it absorbs the heat. When we say absorb, what does it mean? It draws out. That's excellent. That is excellent. So it draws it out or receives it. Both of them make perfect sense. So it absorbs, and what's the meaning of expel? Alright, so that is it. So it forces it out. So we are learning about the heatsink and fan, and we learned that the heatsink and fan is placed directly on what? The CPU. When you look at this old motherboard, where do you think the CPU is? Who can show me where the CPU is? Alright, so this is our CPU on this motherboard, and this CPU, we learned that it generates a lot of heat. it generates what? A lot of heat. As a matter of fact, this is the number one component in a computer that generates the most heat. There is no other component that generates heat like the CPU. And we also learned that the CPU's heat should not cross a certain limit. And so the heat is often regulated by the heatsink. In this, the computer that this motherboard belongs to, this is a heatsink it uses. This is a very old heatsink as well, but it's a heatsink. Whenever you see anything like this, it's a heatsink. Some of them look like what we see in the video, but you can see that it is designed this way, and by just looking at the design you should be able to tell. I believe you've seen this picture. Let me show you the other one. Some of them also look like this. Is this similar? It's quite similar. So whenever you see this aluminum, it says it is an aluminum heat exchanger. So whenever you see this, you know that it is a heatsink. Now, in this particular system, the heatsink sits on the CPU like this. In most computers, the heatsink is the biggest component in the case. Apart from your power supply unit, your heatsink is usually big like this. And in this machine, there is a fan attached to the heatsink. Right now, it is separated, but I'm going to show you the fan very soon. And you can see that this one is, the way it is designed here, it sits directly on top of the what? The CPU like this. And that is how it is designed. It will be screwed down, so it will be attached to it. This is how it is designed, so that it effectively draws or absorbs the heat. Now, when the heatsink is placed directly on the CPU, it needs a certain paste. It needs a certain paste for the heat absorption to be very effective. It needs a certain what? Paste for the absorption and the contact between this and that to be very, very effective. So usually we apply a certain paste here. That paste is called, let me type it on the screen for you to see. It's called the, have you seen it? It's called what? Thermal paste. This thermal paste allows the contact between the heatsink and the CPU to be firm, number one, and the heat absorption process to be more effective. And so the heatsink is never ever placed on the CPU without a thermal paste. It is never ever placed on the CPU without a thermal paste. Are you with me? As a matter of fact, anytime the heatsink is separated from the CPU for any reason at all, a new paste or fresh paste needs to be applied before the heatsink is put back. Are you with me? This is my thermal paste. This is my thermal paste. Let me open it and apply a little bit on it. Okay. All right, so usually we apply a little paste on the CPU like this before we place the heatsink on the CPU. This is how it is done. This is how it's supposed to be. Are you with me? This is it. Is that okay? By just applying this, it's already like glue. Already. You see? It has held it a little bit. I'm trying to remove it, but it's a little difficult. Alright, so I've separated it. So anytime you want to place the heatsink on the CPU, you need to apply your thermal paste. Is that okay? Alright. Now, okay, so over here we have a very old computer case, and this motherboard was removed from this case. Now when you look here, there is one fan here. Please, have you seen this fan? As a matter of fact, this is the only fan in this case. The motherboard lies down here. This heatsink is placed somewhere here. Please, have you seen this? And outside here we have the vents. Every computer system unit has a vent here. Even laptops also have their vents here. The vent is an area where a lot of holes have been created so that air can easily go out and come in. So in this particular system unit, this is the only fan. So the fan is next to what? The heatsink. And the heatsink sits on the CPU, also on the motherboard. Is that okay? Let me show you something else. Okay, first of all, I'll remove the fan. This is how it looks like. And it is designed to expel warm air and bring in cool air. When the fan turns, it is designed to expel the warm air and to draw in cooler air. That is how the fan works. And so this fan it blows air directly onto the CPU. They are together like this. Please, have you seen this? It blows its air directly, sorry, the heatsink. It blows its air directly onto the heatsink. The heatsink also cools the CPU down here. Are you with me? And so this is the cooling system for this computer. This is the cooling system for this computer. Is that okay? I'll show you another system unit and how the heatsink and fan is designed. Then I will talk about another type of cooling system. Alright. Okay, so let's open this system unit and discover how the heatsink looks like and the number of fans in it. Okay. So alright, so who can show me the heatsink? Who can show me the heatsink? Have you seen it?
Yes.
Let me add some more light. Have you seen the heatsink?
Yes.
So this is a heatsink, and you can see that the shape is a little bit different, right?
Yes.
But it is still the heatsink because we can see an aluminium. It's like an aluminium coil, and the way it is designed with the fins, it looks just like heatsink. So we can tell that this is a heatsink. Yes, that is a heatsink, and you can see that the fan is placed directly on top of the heatsink. You can see that. And under the heatsink, what do you think is under the heatsink? The CPU. Alright, so please, do you see the fan? This is a fan on the heatsink. But do you see a second fan?
Yes.
Alright, so some computers have two fans. They have one fan directly on the heatsink and another fan near the vent. So this one cools the heatsink and works together with this one to expel the warm air and also to bring in cooler air. So in some computer systems there are two fans, and other times we have just one. So the first computer I showed you had just one fan. Do you remember? This one has two. Alright. I think I want to remove the heatsink for us to see something. So okay, so let's see. Okay, oh, got it. All right, so this is how it looks like. It's very dusty because when the fan is working, it attracts a lot of dust as well. So once in a while, your computer needs to be opened and cleaned. Every computer gets dirty. It's not only this one. Every computer gets dirty. All right, so this is it. Now, when you check here, you can see that there was a paste on it that has dried off. Can you see something? Yes. And if you check on the CPU, watch this. You can see that the paste was there, right? There was paste. That is a paste that has dried off. So this paste I'm talking about, it looks just like this. This one, it looks just like this. And so it is real. So this paste is applied directly on the CPU. Let me remove the CPU for us to see. Wow, this is a powerful CPU. Well, it's an i3, but it's not a small CPU. Powerful one. Wow. This one is an i3 CPU. If you check here, do you see a sticker on it?
Yes.
What's the sticker? What does it say? Intel Core what? That's a powerful system. It's not like that old one. This is a powerful system. Intel Core i3, that is it here. So this CPU is cooled by this heatsink and this fan. Usually the fan has a cable to connect to the motherboard for power. So when this is connected, then the fan will be able to run. It will receive electricity and it will run. So that is it. Okay. Now, before I proceed, I want someone to tell me the function of the heatsink. What does it do?
It is used to absorb and expel heat away from the
Excellent. That's what it does. Without that, the temperature of the CPU will go too high and the system will shut down and sometimes get damaged. So this is what helps your computer not to go off. Without this, your computer cannot be on for 10 minutes. But do you know that a computer can run a whole day, sometimes 2 days, 3 days without going off? Yes, it's because of the cooling system. This is a cooling system. Alright, so let me fix this one back first. Okay. Bingo. Wow, that's wonderful. So you've seen the heatsink. What am I holding here? Power supply unit. We need to understand that every power supply unit has a fan in it. There's a fan in this unit, and the fan here is also designed for the component within the power supply unit, and that fan cools those components because this is a system on its own and it has several components within it. When you open this, you see a lot of capacitors and transformer and a whole lot of things. So they also generate heat. So the fan inside, I can see the fan from here. The fan cools the components inside. You can see some of the components showing here. You can see, right? Okay. So when we talk about the system fan, first of all, our focus is on the first one connected to the heatsink. Sometimes we have a second one that expels heat and is closer to the vent. And there's always a fan in the power supply unit. So this is not what we are talking about. Okay. Alright, we have some more information here. The heatsink usually has a fan attached to help provide a complete cooling solution for the CPU. The heatsink is usually made from a high temperature conductive material such as aluminum and copper. And it is a key component that keeps the computer running smoothly. Without a heatsink and fan, the processor will overheat and get damaged. Without the heatsink and fan, the processor will overheat and get damaged.
Hello everyone. In this video we're going to talk about CPU cooling, and we're going to talk about the components that are involved in CPU cooling. And we're also going to discuss the two different types of cooling that can be used to cool a CPU, such as air cooling and water cooling. Now, the biggest heat generator in a computer is the CPU. The CPU is the brain of the computer, and it produces an enormous amount of heat in a very short amount of time. In fact, if the CPU were to run by itself without using any cooling components, the CPU would likely fry itself within 10 seconds. So to remedy this problem, a CPU needs a heatsink to help dissipate the heat. A heatsink is basically an aluminum block with fins that directly makes contact with the CPU. And the heatsink's purpose is to increase the surface area of the CPU so that it can make more air contact for cooling. The larger the heatsink, the larger the surface area will be, therefore increasing the cooling ability. The fins on the heatsink are designed to further increase the surface area for air circulation. Once the heatsink makes contact with the CPU, the heat will transfer from the CPU to the heatsink, where the air will cool the heatsink, which will cool the CPU. Then on top of the heatsink would be a fan. The CPU fan is designed to move air across the heatsink to help keep it cool. Now this type of CPU cooling is called air cooling, and this is what the majority of computers use when cooling a CPU. Now it's important that the heatsink and the CPU make the most contact with each other so that adequate cooling can take place. So that's why it's important to apply thermal compound on the CPU before attaching the heatsink. Thermal compound is used to fill in the microscopic air gaps between the heatsink and the CPU to make up for the imperfections of the flat surfaces. Now the surface areas between the CPU and the heatsink are flat, but they are not perfectly flat when examined with a microscope. Thermal compound is designed to fill in the microscopic air gaps so that the most contact can be made between the heatsink and the CPU. Because the more contact that the CPU makes with the heatsink, the better the heat transfer will be, which will keep the CPU cooler. And another type of CPU cooling is water cooling. So instead of using air, this type of cooling uses water to cool the CPU. So for example, here is a water cooling unit for the CPU. There is a pump, hosing, and a radiator. And inside this unit is water. This unit is placed directly on top of the CPU, just like a traditional heatsink, and the pump inside constantly circulates the water throughout the entire unit to help keep the CPU cool. Once the water reaches the radiator, the water is air-cooled by a radiator-mounted fan that draws air into the radiator and cools the water. Then the cycle is repeated, so a constant flow of cool water makes contact with the CPU. So as a result, water cooling cools the CPU better than air cooling. They are also more quiet, but at the same time, water coolers are more expensive. Now, CPU water coolers are not as common as air coolers. So if you were to buy a new computer today, it will most likely have an air cooler instead. Water coolers are more commonly used in high-performance computers, such as gaming computers. Or if you're going to overclock your CPU, then you should use a water cooler.